In this video, we will discuss how to use significant figures in mathematical equations. In a previous video, we discussed how to determine the number of significant figures that a value has. Before you continue with this video, make sure that you have watched that previous video on determining the number of significant figures. So there are two essential types of mathematical manipulations that we will be doing in this semester's work. And the type of mathematical operation that you're doing dictates the reporting of significant figures in an answer. If we're working with addition or subtraction, it will be the value with the smallest decimal measurement determines the answer's significant figures. So for addition subtraction, it will be based on decimal places. For multiplication division, the least precise measurement value determines the number of significant figures in the reported answer. So when we're working with multiplication and division, it will be based on the value that has the least number of significant figures. Let's now look at some laboratory type problems that you will see throughout the semester that deal with significant figures. So let's say first you have a whole bunch of different glassware that you've used to collect various volumes, and you're adding them into one container. And what we want to know is what is the total volume once we mix all the values. Okay, so what is the total volume if containers with 10.1, 6.25, and 25 mils each, respectively, are mixed together? So we're essentially adding the three volumes together. So mathematically, we would write them out as 10.1, 6.25, and 25. Now, one of the things you want to do when you're doing addition subtraction is try to line up your values such that the particular decimal places line up. So the ones place should all be aligned, the tens place should all be aligned, right? The tenths place should all be aligned. You want to make sure that they're all aligned up, which will make figuring out your significant figures a little bit easier. So we're going to add all three of these together. And before I do that, I'm going to draw a vertical line down indicating which value has the least number of decimal places, right? The 25 is accurate, but only till the ones place. The 10.1 is accurate to the tenths place, and the 6.25 is accurate to the hundredths place. So if we add all of these together, we get 41.35. What we would report this as is 41. The reason that we are cutting and rounding off the 0.35 is because we don't actually know that it's a 3 and a 5. We know our values in the ones place, right? We have a 0 for the first number, a 6 for the second, and a 5 for the third. But in the case of the tenths place, we don't know what the value is right here. And so we don't know the effect of adding the 1, the 2, and whatever value is there. Similarly, for the hundredths place, we don't know the value that's next to the 1 here, and we don't know the value here. So we have a very low confidence that this number here is actually a 5. And so we can't really report the answer to that decimal place. The best we can do is say that we're pretty sure that this value is a 4, and that the 1 value here, this is our estimated value. We're estimating that it is 41. The value in the ones place is most likely a 1. And then because we're working with units, we wanted to add the units to them, right? So if we're doing addition subtraction, it's the least number of decimal places is where we're going to cut it. Another one that you'll be doing a lot is taking measurements from a balance and subtracting to figure out how much you added. So here we're going to be subtracting some masses. So let's say you weigh a sample in a beaker and it is 82.23 grams. If the sample beaker weighs 75.735 grams, how much does the sample weigh? This is how you're typically going to weigh out solid or sometimes liquid samples, is you weigh the container, put your sample in the container and then figure out the mass of your sample by taking the difference between the sample in a container and the container itself. So writing this out, we would have 82.23. This is grams. This is the sample plus the beaker. And then we would subtract off the weight of the beaker. Okay, and then to figure out where the significant figure is going to be, we draw a vertical line down to indicate which one had the least number of significant decimal places. Right? So doing this mathematical manipulation, you'll get 6.495. Okay, which, because this is a 5 here, this would round to 6.50. This last zero is significant because it is a trailing zero. It is a zero that comes after the decimal place and after a number, and so it is not a placeholder value. We would also want to include our units of grams, so our end answer would be 6.50 grams. Let's now look at some generic problems for addition, subtraction to give a little bit more practice. So let's say we're adding three numbers together. 1.125 plus 9.85 plus 100.1. So again, we're going to line these all up. 1.125, 9.85, and 100.1. The key is you want to line up their decimal places so that we can figure out which one of these has the least number of significant digits. So in comparing the three, we draw a vertical line down to help us figure this out. So the one that has the least number of significant digits, not significant figures, but significant digits, is our last value, 100.1. It is only significant to the tenths place. The 9.85 is significant to the hundredths place, and the 1.125 is significant to the thousandths place. So when we add all three of these together, we will get 111.075. We will be cutting and rounding between the 0 and the 7, so this would give us 111.1 as being our answer. Looking at the subtraction, we're going to take 7.251, subtract from that 8.35, and then from that we will subtract 12.345. So I'm going to do this one actually in stages so we can look to see how it is working step by step. So we're going to take our 7.251, subtract 8.37. Drawing our vertical line, we can see that we will be cutting this off at the hundredths place. The answer you would get would be negative 1.119. Because we're going to be doing an additional subtraction, we aren't going to cut and round just yet. We will keep track of our significant figure. So in our next stage, we'll take the result of the 7.251 minus 8.37, and then from that we're going to subtract the 12.345. So we'll take the negative 1.119, and I like to use a bracket to denote where the significant figure is. Some other text will underline or use a line above the number to indicate the significant figure. Other places you'll see sometimes they'll use a smaller font for the values that are not significant. So this might be written as negative 1.11, and then they would use like a small 9. They would use a small 9 at the bottom, right? There's a lot of different ways to keep track of significant figures. I prefer writing out a bracket. So that's what you will see me do in subsequent videos. So we're going to subtract from this 12.345. That would give us negative 13.2. 4, 6, 4. Drawing a vertical line down here, and the reason I drew it where I did is because in our first calculation, where the significant figure got cut was between the 1 and the 9. And so where this would actually end up, this value of 9 here is not actually a significant figure. We're keeping it there to prevent a rounding error in our calculation, but it's not actually significant. So when we do this, put this all together, our end answer would be negative 13.46. We will cut and round between the 6 and the 4, and because the 4 is less than 5, this value rounds down to a 6. So our answer would be negative 13.46. Let's now look at some examples of keeping track of significant figures for multiplication and division, starting with multiplication. So we're going to multiply all three of these values together, 11.5, 6.325, and 1.2345. So if you plug that into your calculator, what you'll get is this is equal to 89.79444375. Now, not all these values we're going to keep. With multiplication division, the value with the least number of significant figures is how many significant figures your answer will have. So let's look back at the numbers that we were using and figure out how many significant figures each had. Our first value, 11.5, has 3 significant figures. Each one of the digits is significant, so this has 3 sig figs. The next one, 6.325, has 4 significant figures. Each one of these values is significant, and so we will count each one. Our last value has 5 sig figs, right? The 1, the 2, the 3, the 4, and the 5 are all significant. Now, the one that has the least number of significant figures is our first value, right? This has the least number of significant figures, and so our end answer will have the same number of significant figures as the value that had the least. And so we will cut it off at 3 significant figures, right? 3 values that are significant. So that's the 8, the 9, and the 7. We will cut it between the 7 and the 9 here, and we will round up because the value to the right of the 7 is a 9. So our end answer would be 89.8. That would be our answer, and that is to 3 significant figures. Our next value, we're going to be doing a division. We're going to divide 0.025 divided by 4.251. If you plug this into your calculator, you will get 0.005880969. That is a 0. Okay, so now looking at our values to figure out the number of significant figures, the first 2 zeros here are placeholders, and so our first value only has 2 significant figures. The first 2 zeros are not significant. The 2 and the 5 are. So the first value has 2 significant figures. Our next value, the one that we're dividing it by, has 4 significant figures. Okay, so because our first value has 2, our second value has 4, the one that has the least is the one that has 2 significant figures, this value here. And so we will use that to determine the number of significant figures for our answer. So our answer would then have 2 significant figures. These first 3 zeros are all placeholders, and so we will cut this to 2 significant figures, and that would be cutting it between the 2 8 values, between 8 and 8. Because the value to the right of where we are cutting it is an 8, we will round up. So our value would be 0.0059. Or we could write this in scientific notation of 5.9 times 10 to the negative 1, 2, 3, 3 decimal places to the right, so this would be to the negative 3. Either one of those answers would be valid. Often you will write things in scientific notation if you have a good number of zeros, if you're working in like the thousands or the thousandths, right? So once you hit about 1,000, then typically you'll switch to using scientific notation, or if you have 2 or 3 zeros before your numbers, you'll also use scientific notation. Up until now, the examples that we've been looking at were using only one type of math: all addition, all subtraction, all multiplication, or all division. But a lot of the times in the things that we'll be working with, we will be switching between multiple different types. Sometimes we'll have addition and subtraction. Sometimes we'll be working with exponents, multiplication, division, things with parentheses. So when we're doing that, we need to think about the order of operations. Now there's an acronym, PEMDAS, P-E-M-D-A-S, that is a good mnemonic for remembering the order of operations that you will be using. The P stands for parentheses, the E is for exponent, M is for multiplication, and D is for division. A is addition, S is subtraction. This is the order that you will go in. First, you will do things in parentheses. This includes functions such as the sine, cosine, or different mathematical function. Then you'll do things that are in the exponent, then multiplication, division, addition, subtraction. And when there's multiple things that are like all addition, subtraction, you work from the left to the right. Let's now look at some examples where we are using multiple different types of math: addition, subtraction, and multiplication, division. Now, when you switch between multiplication, division, and addition, subtraction, you're going to need to collect your answer and mark the location of your significant figures before moving between the different math types. We will again be using our PEMDAS to tell us the order that we will be doing these operations in. So for our first example, we are taking 1.34 times, in a set of parentheses, 102.3 plus 2.553. So using PEMDAS, we will do the parentheses first. So we will do this part here first, and then we will multiply by the 1.34 times the resulting answer from step 1. In doing this, we will be switching between addition, subtraction for step 1 and multiplication for step marked 2. So first, we will take our 102.3 and add to that 2.553, marking the location of where our significant figure will be. You get 104.853. Now, if we were to take this as being the answer, if we were only doing the addition subtraction, we would cut and round the value now. But because we are continuing with the math, we will note where the significant figure is, but continue to use a couple additional digits. Typically, if you keep 3 additional values, you will prevent from introducing a rounding error into your calculation. We have 2 digits here, so we're going to just keep the extra 2. If you have something that has more than about 3 extra digits beyond where your significant figure is, you only really need to keep 2 to 3 digits to prevent a rounding error. If you're going for high accuracy, keep 3 just in case. But typically 2 to 3 is enough to prevent any sort of a rounding error from occurring. So we're going to take our 104.853 with the significant figure falling between the 8 and the 5 and multiply that by 1.34. So we're going to take 1.34 times what was in the parentheses, which is 104.853 with a significant figure being between the 8 and the 5. Plugging this into your calculator, you'll see that this is 140.50302. Okay, looking at our values to determine which one has the least number of significant figures, our first value has 3 sig figs. Our second value, in terms of once we cut where the significant figure is, that's between the 8 and the 5, this has 4 significant figures. The 5 and the 3 are not significant. We are just keeping them to prevent a rounding error. So the one with the least number of significant figures is the 1.34, and so our end answer will have 3 significant figures. So our end answer would be 1, 4, and then we're going to cut between the 0 and the 5. Because the value to the right is a 5, it will round up. So our end answer would be 141. Okay, looking at another example. This time, we don't have a set of parentheses around the addition subtraction. This time, we're going to take our value and look to see what we get. So, using PEMDAS, we don't have any parentheses. We don't have any exponents, so then we do multiplication division before we do addition subtraction. So we have multiplication division, and so we will be doing this part here first, and then we're going to take the answer from that multiplication and then do addition subtraction second. Okay, so doing the multiplication division first, if we take 25 times 1.25, we get, so 25 times 1.25, plug that into your calculator, you get 31.25. Now, because we're switching between types of math, we're going from multiplication division now to addition and subtraction for part 2, we need to figure out how many significant figures we have. So our first value has 2 sig figs, and our second value that we're multiplying together has 3 sig figs. So the answer, or the result of that multiplication, will have 2. It will have the same as the value that had the least number of significant figures, which was the 25. So this will only be significant to 2 significant figures, so between the 1 and the 2. So it will be significant to the 1's place. Now doing our subtraction, we would take 105.6 minus 31.25 with a significant figure between the 1 and the 2. So drawing a vertical line to indicate where our significant figures are, it would be here. Right? So it would be after the 1's place. So doing the subtraction, you get 74.35. So collecting our answer, that would be 74. We will be cutting and rounding between the 4 and the 3. The 3 is less than 5, and so it rounds down to 74. So our answer here would be 74.